Hi everybody, I'm Pat Goss and this is Goss's Garage, brought to you by Wynn's Automotive Products. Now, one of the things that we have facing us is that, well, the cold months are coming up for a lot of the country, and even in the warmer parts of the country, we're still looking at potential problems that we could have with one of the basic parts of our automobiles, and that's the automatic transmission. Now, I know if you go to a dealer, the dealer's probably going to tell you that automatic transmissions are sealed for life and that they never need service. Well, golly gee, somehow they must have figured out a way to defy the laws of physics. You see, in reality, so far, nobody on planet Earth has managed to make a lubricant, an oil, or anything like that that lasts forever. They all break down. And today, they all have additives in them. And the additives in the oils, in the engine oil, in the transmission oil, in the differential oil, all these different fluids, the additives break down over time and use. So, how can we say that something is sealed for life and never needs service? Well, I had a customer the other day that found out. The dealer had told this individual that his transmission did not need service, that it was sealed for life, had lifetime fluid in it. So he bought that sales pitch. Well, what did he do next? Well, he continued to drive the vehicle, and the transmission ultimately failed at about 100,000 miles. Never had anything done to it. Goes back to the dealer, says, my transmission failed. What should I do? Well, the service advisor says, not a problem. You have to buy another one. But he says, you told me it was sealed for life. It didn't need any service. It was lifetime fluid and all that. Service advisor says, yes, that's absolutely true, and we just proved it. It lasted the life of the transmission. Now, okay, so transmission fails, that is the life of the transmission. I'm not sure, and I'm reasonably sure that not all dealers are going to take a position like that and be that crude and offensive and so on, but there are going to be some out there that do. The big thing is that automatic transmissions, if you service them on a regular basis, ideal is no more than 3 years or 36,000 miles. Uh, so you use your own judgment as far as that's concerned. Now, there are two ways to service a transmission. Number one is one that we don't want anything at all to deal with, and that is the old-fashioned way where they drop the pan or they remove the drain plug, they drain part of the fluid out of the transmission, then they refill it. Okay, why is this bad? Well, it's bad because it doesn't clean anything in the transmission. Nothing is being put in there to clean it. You are only changing a quarter or a third of the transmission. So all of the majority of the dirty, nasty, worn out transmission fluid is staying in your transmission. Okay, that means that over time, that dirt can circulate through the transmission. It can clog passages. Clogged passages cause slipping. Slipping causes heat, and heat shortens the life of the transmission. So what should you be doing? Well, you should be flushing the transmission. Not a drop the pan and change part of the fluid, but flush it so that you change all of the fluid. Plus, flushing uses chemicals that clean the inside of the transmission. And they clean the inside of the torque converter because the chemicals in the fluid are flowing through the torque converter. Now, why is the torque converter an important part? Well, if you stop and think about how things work, a torque converter is this round device, has vanes in it that look like the vanes on the front of a jet engine because it works somewhat in a similar manner. All right, now the fluid on the outside, it spins with the outside of the torque converter, and that causes this fluid to move. And as the fluid moves, it causes the inside of the torque converter to move, and that drives the transmission. It's a fluid coupling between the engine and the transmission. All right, now, you know how high your engine revs up. You got a tachometer on the dash. Probably during acceleration, you may see 3 or 4,000 RPMs. Normal may, as you're cruising along, may be down as low as 1,200. It might be 2,000, whatever. But the thing of it is that the torque converter is turning at engine speed. Now you've got fluid in this torque converter that is spinning with the torque converter. Now what does that make that torque converter? Well, from a practical sense, it turns it into a centrifuge. Now, you've seen or heard about centrifuges. They're used in medicine and all sorts of different applications. And what it does is by spinning something circular at a relatively high speed, it causes various components in that liquid to separate and move outward toward the outside of the spin. The heavier things go to the outside. Now, consider that you have dirty transmission fluid. All transmission fluid has some contaminants in it if it's been used for even a few thousand miles. Now, as that torque converter spins, it acts like a centrifuge and causes the dirt to fly out to the outer inside edges of the torque converter, and it just kind of hangs there. All right, over time that builds up. And if you don't flush the transmission, it'll continue to build up to a point where pieces of this dirt get big enough that it will start to flake off. And as it does, the particles in it may separate, and they can be small enough that they actually move through the filter. That is, if your transmission actually has a filter. A lot just use a metal screen these days. Okay, but anyway, these dirt particles are so fine that they can pass through the various passages inside the transmission, and they can also clog some of those passages. Now that normally happens when you have a very fine channel in the valve body of the transmission that has a curve in it. Just like you see, if you're a boater, you travel a river and there are bends in the river, you see how the dirt and so on builds up on one side of that river. And that's because of the way currents flow and so on. Well, it happens inside these curved passages in the valve body in your automatic transmission. On these curves, this dirt builds up and gradually restricts the flow of fluid. Now, it doesn't completely stop the flow of fluid, but when it restricts the flow of fluid, that means that the clutches inside the transmission that account for the various shifts and so on, these clutches have to come together and they grab each other. There's a whole bunch of them, a stack of clutches called a clutch pack. And when these things have pressure applied to them, they come together and they turn together at that point. Release the pressure, they release, they do not turn together. All right, so what are we looking at here? Well, if we reduce the pressure that clamps them together, we get more slippage. And you think that's great because as your transmission has aged, gee, the shifts are smoother than they ever were. Well, that's not a good thing because the smoother the shift, in most cases, especially if it's a change from when the vehicle was new, that means that you're getting more slippage. More slippage on the clutch discs mean that they operate at a higher temperature. And because they operate at a higher temperature, they don't last as long. So the higher the operating temperature, the shorter the life. And the more restrictions we have inside that valve body that controls the application of those clutches, well, the more slippage, the more heat, the shorter the life in your transmission. Now, when we flush a transmission, what we do is put a chemical in, then we run the car. The chemical cleans, loosens this dirt, cleans it, gets it into solution with the fluid inside the transmission. Then the flush machine takes that fluid. We put the flush machine in series with one of the transmission cooling lines in most cases. And as that fluid passes up that cooling line, it's diverted through the flush machine, and we take that old fluid out, we quarantine it outside of the car in that flush machine. Then the flush machine puts new fluid back into the transmission. So we're quarantining all of the old fluid, adding new fluid, and we're flushing all of the dirt, debris, and everything out of the transmission. So that's the thing that you want to have done to your transmission so that it will last a lot longer. Lots of times, routine flushing many times can double the life of your transmission. And transmissions being what they are today, 7, 8, 9, 10 speeds, believe me, you don't want your transmission to fail, especially when the car is out of warranty, because they are expensive. All right, we'll talk a little bit more about automatic transmissions in a minute, but now we are going to take a break for a word from Winns. Modern automatic transmissions can be traced back to 1904, when the Sturtevant brothers of Boston developed a clunky, inefficient, failure-prone centrifugal gearbox. A crude beginning and nothing like today's transmissions, which shift smoothly, deliver great fuel economy, good performance, and exceptional durability. However, the sophistication of today's transmissions means repairing or replacing a broken one now costs more than a whole fleet of cars did back in '04. To keep your transmission working its best and help avoid costly repairs, I recommend the Winns line of transmission care products. Winns has a complete line of chemicals and service equipment like Winns two-step premium automatic transmission service kit, which cleans varnish deposits within the transmission and suspends those deposits in the old fluid for easy removal during the transmission service. Winns Premium Automatic Transmission Treatment enhances the properties of new ATF to make it more effective and last longer. Ask for quality Winns products by name at finer shops everywhere. Online, winnsusa.com. Hey, also check out our friends at Rock Auto. All the parts your car will ever need. rockauto.com. All right, we've been talking about automatic transmissions and flushing them. Now, one of the things that you have to remember about automatic transmissions is that many manufacturers these days have vehicle-specific transmission fluids. All right, now what's different from one fluid to another? Well, one of the factors that is different is how gritty it is. Let's put it that way. Here we have examples of different types of sandpaper. The one over here, you might not be able to see the difference, but you could certainly feel the difference if you were up close to it. And what we have, this one is very coarse, this one is very fine. Doesn't look that much different, just like transmission fluid doesn't look that much different. But The fact is that the amount of friction that the transmission fluid applies or adds to the clutches in the transmission, well, it's different from one fluid to another. The other thing about this frictional characteristic of automatic transmission fluid is the chemicals that make that in the fluid, they're worn out over time. That means if it was an aggressive, like a coarse sandpaper, when it was new, you get 30 or 40,000 miles on it, it's nowhere near as aggressive because the friction modifiers in there have worn down. And that means more slippage, more heat, and shorter transmission life. Now that also means that when you go to the shop to have your transmission flushed, you want to make sure that they use a fluid that is appropriate, that it matches the requirements for your particular car. If they use just one fluid across the board, well, you might want to look for a different shop because there are differences in these fluids. So flush the transmission, do it on a regular basis. Oh, by the way, if you do the WINS transmission flush, check with your WINS dealer, but you'll get a warranty as well. So that helps the downside. All right, now, from the ridiculous to the sublime, this week's questions. How do you know if a Cadillac, C-A-D-I-L-L-A-C, how do you know if a Cadillac converter is bad? Cadillac converter. Well, Cadillac converter. I'm not sure how you know if one is bad, but after spending weeks doing research and not finding any reliable test procedure, I sort of I got to guess. I would think the best way to see if it's working properly is to put your money into the money slot on the Cadillac converter. Push the appropriate buttons to tell it if you want to convert something into a Cadillac or convert a Cadillac into something else. Maybe you've got a problematic Cadillac and you want a Rolls Royce. You know, a Cadillac converter, I'm sure if it converts Cadillacs, could convert it in just about anything you wanted. Okay, next, push the enter button and see what comes out the other end. If it matches the buttons you pushed, it's working. But if what comes out doesn't match, well, your Cadillac converter isn't converting properly. All right, now, if you really don't know that it isn't a Cadillac converter, writer, if you actually don't know, and if you actually want to know about a catalytic converter, look for a check engine light and a code PO420, PO420. Ay. Anyway, you know, like I say, some of these questions, and most of them come from Quora. I do a lot of answers on Quora, so if you have something that you would like me to answer, you can present it on Quora, or you can email me directly, Pat Goss at goss-garage.com, or service@goss-garage.com. All right, next one. What's the point of a rear spoiler on a vehicle? Well, of course, on a street-driven car, used legally, none whatsoever. See, it looks good, but has no effect at legal highway speeds. But now if you're going to the track and are capable of over 100 mile per hour speeds, your handling will be improved. But on the street, nah, they're looks. They're posers for a lot of people. That's all. All right, next question. Is it possible by actual materials, alloys, technology, even experimental, to build a car which would resist with very minor damages, or none at all, impacts of say 200 kilometers per hour. Maybe it wouldn't make a big difference for the drivers, but I wonder. Well, of course it could be done. It has been done. There have been all sorts of vehicles that have been made with giant bumpers around them and airbags around, all sorts of different things. And those things were done many years ago, back in a time where they didn't realize quite so much about energy and physics and so on. But making cars that don't bend in an accident is very dangerous to the occupants. The reason cars are made so they collapse in an accident is to absorb some of the energy of the collision and to gently slow the vehicle. You see, you're traveling at the same speed as the vehicle. So if you're going to get hit, let's say you're driving down the road at 60 miles an hour, your body is traveling at 60 miles an hour inside that vehicle. Now, what do we want to do? Do we want to stop the vehicle instantly with it not absorbing energy? Well, no, we don't want that, because that means that if your body stops instantly, your brain can move inside your skull because of this tremendous G-force of stopping instantly. Your other organs can be damaged simply because the G-forces are too great during that instant stop. Now, the way cars are built, they are built so that parts of the body absorb energy. They collapse. And as this is happening, the car is slowing ever so slightly. And that means that you inside the car are slowing ever so slightly as well. Now, combine that with airbags and seat belts and all the rest of it and so on, and you have very safe cars these days. That's because of this energy absorption of the body of the car. Let's face it, cars, they're building them all day long, every single day. So cars are easy to replace. The car lots are full of them. Go to any dealership and they'll have hundreds of brand new cars. They may have hundreds of used cars. So replacing the car is not an issue. Replacing people is an issue. That's why these cars are designed the way they are. And if you think, oh gosh, that wasn't that bad an accident and the whole front end of my car is destroyed, the car's totaled. All right, which would you rather have? A totaled car or a coffin? These things are designed for a purpose, and that purpose is to save your life. So don't think just because there was a lot of damage to your car in a seemingly minor accident that there was something wrong with the car. No, that's the way it was built. All right. How long does a check engine light stay off after resetting? Resetting? There is no resetting of a check engine light. MIL, CEL, check engine light, malfunction indicator light, whatever you want to call it. Yellow light with a little picture of the engine. Don't reset them. You can't reset them. What you have to do is you have to test to see why that light is illuminated. Once you find out why that light is illuminated, then there's a test procedure, and once you get the repair done, you retest to make sure the problem is gone. Now, after you've done that and the problem is gone, you can, with a scan tool or something, and if you have the right type of scan tool, you could redo the check engine light right there, erase the code and so on. But unless the problem is fixed, if it's a hard failure, the minute you start the car, the light's going to come back on. So the way to get that light to go off is to figure out why the light is on. Then what you do is you drive the car, or you do the repair, then the car has to be driven, and once the car's computer sees two consecutive, it has to be two consecutive, back-to-back drive cycles with the problem gone, the computer will turn the light off. But if the problem is still there, well, the light's going to come back on, except when you do one of these jackass things like you see on the internet. Oh, disconnect the battery cable and you will erase the codes and do all of this stuff. The light will be gone, and yeah. Yes, the light will be gone, but you haven't fixed anything. You see, inside your computer, there is the main computer that controls everything. And then overseeing that main computer are a series of what are called monitors. Now, these monitors have to see certain operating conditions before they are set and ready. Now, for that light to come on, all of these monitors have to be set and ready. Now, when you disconnected the battery cable, what you did is you wiped out all of those monitors. Now, this car has to be driven under certain conditions to reset those monitors. Now, some of those conditions are pretty ridiculous. You might have to drive at over 50 miles an hour, but less than 55 miles an hour for 4 miles. Now, I don't know how you actually go about doing that by design, because if your traffic is anything like our traffic here in Maryland, finding 4 miles where you could maintain a steady speed like that's going to be pretty difficult. But anyway, that's what's required on one model that I think of. And at the end of that, you have to go for so many miles or so many minutes. Then you have to decelerate to 25 miles an hour and maintain 25 miles an hour for X number of minutes or miles. Then you have to come to a stop and let the engine idle. Then you have to accelerate and get it up to 60 miles an hour in less than blank seconds. And I mean, it gets very complicated. It takes all of these different criteria in driving to reset those monitors. Well, while those monitors are not set, that check engine light can't come back on. So you pull the battery cable off, put it back on, start the car, check engine light's gone. Oh, hey, I fixed it. Gosh, wasn't that guy on the internet, wasn't he a miracle? No, he wasn't. He didn't fix anything. Code's still in there. So if you're trying to get the car through emissions, it isn't going to pass, because at the emissions station, the first thing they do is they turn the key on, make sure the check engine light lights up, then they start the car, make sure the check engine light goes out, and at the same time they've got a scan tool hooked up to the computer interface. And what they look for there, number one, monitors. Are they set and ready? Yes or no? Yes, go to the next step. No, it has just failed your emissions test. And because you erased those monitors and you haven't driven it far enough to reset them, and you didn't do anything to fix the code, you're not going to pass emissions. Just that simple. You know, when they designed all these things, they thought about all of your different hacks and so on to get around the system. Well, that really doesn't work. So they thought about those things. So you don't really outsmart your car or your car's computer or the emissions laws. All right. Well, that about does it for this episode of Goss's Garage. Couple of things. Number one, if you want to contact me, it's Pat Goss at goss-garage.com or service@goss-garage.com. Be sure to look for Wynn's products. They make the show possible. Also, check out rockauto.com where they have all the parts your car will ever need. Until we meet next time, a couple of things. Make sure you enjoy your fish head pudding, and also drive gently. See you next time, right here in Goss's Garage.